welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on Form 1 chemistry, and specifically, we are going to be looking at the topic water and hydrogen. And today, we are going to be looking at the reactions of metal with steam. So, this is going to form the second part of these subtopics we have been discussing from the previous lesson. So lastly, we talked about the reaction of magnesium and aluminium with steam. So we're going to continue with these reactions of different metals with steam. And for today, we are going to specifically look at the reaction of zinc with steam. And then we are going to also look at the reaction between iron with steam. And we are also going to introduce the reactivity series. And this series is going to be related to the reactions of metals with steam and the reactions of metals with steam and water. And then finally, we are going to do a few questions in regards to what we are going to discuss today. So let's start with the experimental reaction of zinc with steam. So first of all, our zinc was placed, a small amount of wet sand was placed at the bottom of the beaker, and then also a small piece of zinc was put in the middle of the combustion tube. Then zinc was heated strongly, and then the wet sand is warmed also gently. And then the delivery tube also in this experiment was removed before heating stops. And then the gas that was produced was tested with a burning splint. So also the resultant solution was also tested, and then we also going to remember to look at the observations on the metal as well, just like we did before. So the first thing that we observe is that zinc metal does not burn, rather it glows. This is completely contrary to what we noticed with aluminium and also with magnesium. So zinc glows, and then the gray solid will change to form a yellow solid. And this yellow solid, as you can see from the images shown, it cools to form a white solid. So the yellow solid is usually when it is hot, and then the white solid is when it is cool. So that is how it moves from gray to yellow, then to white. So you can mention the three colors, especially when you are explaining your observations. And then there was an evolution of a colorless gas, and the colorless gas produced a pop sound when a burning splint was introduced on the gas jar. Remember, the hydrogen was being collected by overwater method using a gas jar. So when that gas was tested with a burning splint, it burned with a pop sound. That confirms that this gas was hydrogen gas. And then we said that the delivery tube is removed before heating stops. This is because we do not want the suck back of the water. And also we said that we do not want this water to go back into the boiling tube because it's going to cause it to crack. So that's the reason why we remove the boiling tube while heating is still continuing. Otherwise, there's a vacuum that is created that sucks back the water into the boiling tube, and as a result, the boiling tube cracks. So when you look at the equations for the reaction, so zinc will react with steam. So you can see the color of zinc. It is important for you to know the color of the zinc in the beginning of the reaction, and then the color of zinc oxide, which is a product. So it's yellow when hot, and then white on cooling, and then hydrogen gas is also produced. So this is the word equation. You can also be taught to write a chemical equation. So if you are taught to write a chemical balanced equation, you can see this is an equation. So zinc reacts with water, but in gaseous state, to form zinc oxide and hydrogen gas is produced. So next we are going to look at the next metal which we used for this reaction, which was iron. So also a small amount of wet sand is put at the bottom of the boiling tube, as you can see, and then a small piece of iron was placed at the middle of the combustion tube or the boiling tube. And then also a delivery tube was attached to the combustion tube, and which was attached to a gas jar placed on top of a trough containing water. The iron was heated strongly and then also the sand was warmed. You can see there's a difference in the heating because these ones are metals that are not that reactive in comparison to the other metals. And then the delivery tube is removed before heating. And then the gas that was produced was tested with a burning splint. So let's look at the observation. So the first thing that you notice is that the metal will not burn, but it will glow. This is similar to when we were reacting zinc with steam as well. So you can see it's going to glow, and then you will see a gray solid of iron forms a black solid. So we are moving from gray, and you can see also from the image, it's a gray iron, and then it forms a black product, and the black product is called triiron tetraoxide. So we have 3 atoms of the iron and 4 atoms of the oxygen. So if you were to write that formula, it would be, so 3 atoms and then oxygen, it's 4. So this is the triiron tetraoxide, and this is the one that is in black in color. And then also another observation is a colorless gas is given off. And this colorless gas, if you introduce a burning splint on this colorless gas, it's going to burn with a pop sound. And this will confirm for us that this is hydrogen. We said that the delivery tube has to be removed while heating is continuing. We said is to prevent suckback of the water, to prevent suckback of the water, of the water. This which will cause the uh, boiling tube to crack. So that's what happens. So we have to allow the delivery tube to be removed while heating is continuing. Next, we are going to look at the equations for the reactions that we have just discussed. So iron, which is gray in color, reacts with the steam, which is colorless in color, and then it forms a black solid, and we have called it triiron tetraoxide, and also hydrogen gas is given off. That is the reason why it burns with a pop sound. It confirms for us that it's hydrogen gas that is being given off. So this is the chemical equation, and then finally other metals. You're going to look at also other metals because you come up with the reactivity series. So lead, copper, mercury, silver, and gold and platinum do not react with either cold water or the steam. So these metals can be arranged in order of their reactivities with both water and steam. And as a result, we come up with an arrangement which we'll call the reactivity series. It's usually similar to the one that is obtained when metals react with oxygen. And when we look at the reactions of these metals with both water and steam, we can be able to see those comparisons. So when we look at the metals like potassium, sodium, you notice they react very explosively and violently with both water and steam. And if you look at calcium, it reacts moderately with water, just like we saw in the previous lessons, and it reacts violently with steam. So that is the reason why we didn't use it in these reactions. When we looked at magnesium, you also saw that it reacted very slowly with water, but it's very rapid with steam. We can see how it glowed and reacted very quickly with steam. But for the metals now below aluminium, they had no reaction with water. And if you remember, we talked about aluminium not reacting with water because it forms an oxide layer. This oxide layer is the one that prevents it from reacting with water. So this is also the reason why it doesn't react completely with the steam. The reaction will start and then stop. That's the reason why we say it is slow. Same applies with zinc and iron. Their reactions are very slow with steam, but they do not react with water. And you can see they actually glow when they react with steam. And finally, our lead and copper do not react both with water and with steam. So with these reactions, we are able to come up with a reactivity series that is specifically made for reactions with metals, with water, and the reactions of metals with steam. So this is the reactivity series. You can see potassium is the most reactive, followed by sodium, followed by calcium, followed by magnesium, followed by aluminium, followed by zinc, followed by iron, followed by lead, and finally copper. So this is the reactivity series in regards to the reactions of metal with water and steam. So the ones that are most reactive are on the top, the ones that are least reactive are the bottom. So it is quite similar to the reactivity series with the reaction of metals with oxygen, although for the one that we discuss in oxygen, reaction with oxygen, we are able also to include other metals that we have not included in this case. So let's look at one question in regards to what we have discussed. A student set up the experiment below to collect gas K. The glass hull was heated before heating zinc powder. So you can see the glass hull is soaked with water and then it's heated and then zinc powder is also heated and then this cascade was produced. So this cascade we know from this reaction is when the glass hull is heated, it produces steam. This steam is the one that reacts with zinc powder to form zinc oxide and then hydrogen gas is given off. So gas K is going to be hydrogen gas. So the question is, why was it necessary to heat the moist glass hull before heating zinc powder? So we heat the moist glass hull first of all to produce steam, and this steam is going to be used to react with the zinc. The other reason is to drive out the air that is initially in the apparatus. If you are not able to drive this air out, it's going to react with the zinc and oxidize it to form zinc oxide. So we do not get our final product, which is the hydrogen gas that we want at the end of the day. So to produce steam, this steam reacts with zinc oxide and also to drive out the air in the apparatus. So because we do not want that air to oxidize with zinc to form zinc oxide before the reaction begins. So this brings us to the end of the reaction of steam with metals. This also concludes the subtopic that we have been discussing. In the next topic, we are also going to look at the other reactions and we are also going to proceed with what we have been discussing. So see you in the next lesson.